The third example in this section deals with exponential functions. And when I look at these exponential functions, x equals e to the negative t and y equals e to the t minus 1, there doesn't appear to be anything that I can really substitute one in for the other and simplify really easily. I seem to have this exponent with an exponent situation. So what we're going to need to do is we're going to need to convert to logarithmic form. Now, let's start by looking at our first piece right there. X equals e to the negative t. What is the domain of that original function? Well, I know right here, e to the negative t, I can plug in anything for t, and it would be defined. So this actually has a domain of negative infinity to infinity. But you also know that e to the negative t, what's the range going to be? Well, if you don't remember, you can pull out your calculator, and let's do a quick little e to the negative t, or in this case, e to the negative x. And I can see that my e function has a horizontal asymptote at y equals 0, which means the result of this function, this x equals e to the negative t, that result is always positive. So the result is always greater than 0, or the range is always greater than 0. That's going to be a key later on. The other piece you want to look at is the relationship between the natural log and exponentials. We know the ln of a equals b. If I were to convert that back and forth, that's e to the b equals a. Now we also know that logs and exponentials are inverses of each other. So right here, if my original function had a domain of negative infinity to infinity and the result had to be greater than 0 for the range, that means in my log, when I switch it, my domain is now going to be greater than 0 and my range would be whatever the result is of that domain, negative infinity to infinity. So that's going to become key as we look at the most restrictive domain. Once I take the inverse, I'm now going to be using this domain. So let's start here. And first we're going to write as a log equation. First step is we'll write as a log equation. X equals e to the negative t. That, if we convert, is the same thing as negative t is equal to the ln of x. Then we can divide both sides by a negative 1. So t equals negative ln of x. And we know that when we've got that negative in front, we can sort of pull it up to the exponent. So t is equal to the same thing as the negative, or natural log of x to the negative 1. So now that I've got t written as a log equation, solve for t, I can plug t into the second equation. So y equals e to the t minus 1. I know t is the same thing as ln of x to the minus 1. And I know that e and ln are inverses of each other. So ultimately, those guys will just cancel out. And I'm going to be left with x raised to the minus 1 minus 1. And that we know simplifies to 1 over x minus 1. Now, if I look at just that function, I would say x cannot be equal to 0. But remember, we've got to take the most restrictive domain. And the most restrictive domain came from up here. When we originally had the range had to be greater than 0, when we took the inverse, the range became the domain. So now my most restrictive domain is that x has to be greater than 0. So I'm using that range that was originally greater than 0. When I took the inverse, the range became the domain, and that's my most restrictive domain. So if I look at 1 over x minus 1, if I were to graph that, I would have a rational function with two curves, one in the third quadrant, one in the first quadrant. But since the domain has to be greater than 0, my graph is going to only be in the first quadrant. I'll have that horizontal asymptote at y equals negative 1. That's that vertical shift 1 down. I'm going to have a vertical asymptote at x equals 0, since that's my undefined point. And my graph will curve down something like that. Now let's confirm that that's what our graph should look like. If I were to graph this in rectangular coordinates, I would use this 1 over x minus 1. So 1 divided by x minus 1. We've already said it's going to be in the third and the first quadrant. But we know we can't include this piece since the domain has to be greater than 0. So we're only looking at this piece right here. So let's convert to parametric form. Make sure we get the same graph. And parametric form was originally e to the negative t. And then y was e to the t minus 1. And if I hit graph, I'm going to see the piece that's only in the first quadrant. Now some of you are probably saying, well, where did this piece go down here that is the horizontal asymptote? Well, we're looking at this when time is equal to 0. And my starting point is going to be right there. And if I go look at it, when time is equal to 0, my x is equal to 1. I have to go back to where time was negative. And if I look at my window, I can see my t-min is 0. If I were to set my t-min to say negative 30 and then hit graph, I'll see my negative time, which is over here. It'll eventually come up. There it goes. Goes to the point 1, 0, which is when time is equal to 0, and then shoots up.